All right, we're finally to naming. So we talked about cations, we talked about anions. We're going to name ionic formulas today that are from the representative elements. Representative elements are from the S block and from the P block. So with your representative elements, when you're looking at them on the periodic table, they always have the same charge. So it's something like in group number 1 or group number 2, those always have a +1 or a +2 charge. We're excluding hydrogen from +1 for right now. It's something like, I don't know, group number 13 down here. You really won't have anything from here, from your 14, 15. But you're really looking at group 1, group 2, and group number 13 with these. The reason being, they always have a +1, they always have a +2, they always have a +3 charge. So when we have a charge that is always the same, you're always going to use a pretty simple set of naming rules in order to attack the nomenclature for these. So these are only for representative elements, and what you're going to do when you need to name the formula, all you do is you name the cation. Cations are really easy because they are always the same. You don't do anything different there. With your anion, you're going to change the last part of the element to end with IDE. So that was where fluorine became fluoride, or oxygen become oxide, or sulfur becomes sulfide. So you're going to take the cation, it stays the same. The anion, you're going to change the ending to end with IDE. You always change the ending of your anions unless you have a polyatomic ion. If you have a polyatomic ion that's present, you cannot change the name or the formula. So if you have sulfate, if you see SO4 in parentheses, or not in parentheses, but usually it's in parentheses, you're just going to call that sulfate. If you have OH, that's hydroxide. If you have CrO4, you're going to have chromate. So no matter what, your polyatomic ion names are going to stay the same from your list. Anions on the periodic table, you change the ending to end with IDE. Now if we have the name and you have to write the formula, we're going to swap and drop like we did in the last video. So if you need to refresh on how to swap and drop, you might want to stop for a second, go back and look at that swap and drop, and then come back to this. And then just remember to reduce it down if you can. So if we have a polyatomic ion there, you cannot change the name or the formula. It's always going to remain the same as it is on your list. PAI, you'll see that quite a bit this year, is polyatomic ion. So those are those groups of elements that you're going to find on the back of your periodic table that will always stay the same. So we've got these examples here. We've got calcium oxide, aluminum chloride. When we have a name, we need to write the formula. When I have the formula, you have to write the name. Now I will give you a warning as I'm switching over to my document camera here. If you Google these, you're going to come up with a lot of organic compounds and compounds of not so simply named or written with formulas. A lot of times they're going to use an organic-based polyatomic ion, for example. Don't Google these, just do the work. It's pretty obvious when you do Google them and you're not learning how to do this, and it's going to come back and bite you later on, especially when we get into chemical reactions. So just do the work. So how we do these, we have calcium oxide. I have the name and I have to write the formula. Calcium, my cation, on the periodic table lives in group number 2, so it has a +2 charge. Oxide, IDE, that one's oxygen. Oxygen lives in group number 16. It has a -2. Those charges are the same. So if they have the same charge, the 2 and the 2 are going to end up canceling out automatically, because if calcium has 2 valence electrons, oxygen has 6. This electron's going to plug in there. This electron's going to plug in there. So you end up only needing one of each in order to make your elements cancel out. So when we write this, it's just CaO. The next one is aluminum chloride. Aluminum is Al +3. It lives in group 13, so it has a +3 charge. Chloride is Cl. It has a -1 because it's a halogen. So again, my plus and my minus are going to disappear. This 3 is going to travel over here. There's a ghost 1 right here. It's going to go over here. So you're going to have Al, that's a ghost 1, Cl, 3. Now on the next two, you have the formula and you need to write the name. You don't need the periodic table unless you have to look up your elements for this one. You ignore the numbers. When you're writing the name, you don't put the numbers in with the words. Like I don't have a 3 here after my chloride. So there's 2 cesium here, there's 1 selenium. So all that I do is I name my cation. My cation here is cesium. Se is selenium. Selenium becomes selenide. Now when I'm writing out the names like this, capitalization doesn't matter. You can capitalize these if you want to. You don't have to. You could use a lowercase and a lowercase. That's completely up to you. When you're writing the formulas, you have to use proper capitalization. Element symbols always start with a capital letter first, lowercase letter second. So if I wrote this as CAO, that would be wrong. You would not get any credit for that one. You'd have to write it capital C, lowercase a, and then capital O. These doesn't matter. I mix it up all the time, whether it's capital or lowercase. IN is indium. Cation name stays the same. BR is bromine. Bromine becomes bromide. So this one's just indium bromide. Now to show you another one with a polyatomic ion, MgSO4. Mg is magnesium. SO4. Now when you're looking for these, cover up the Mg because that's your cation. Everything after the Mg is your polyatomic ion. So that's where you're going to get out your polyatomic ion list. If you don't know this one yet, it's SO4 right here. That's called sulfate. So we would write down sulfate. That name cannot change. It has to stay in place. Just to show you one more with a polyatomic ion. Sorry, I'm making this one up. SrOH2. If you have SrOH2, Sr is strontium. My OH in parentheses there. The parentheses tell your brain, hey, I've got a polyatomic ion. I need to look at my list, or you might just know it after the first couple times you try it. But OH is hydroxide. I have to write that down exactly as it is in my list. So SrOH2 is called strontium hydroxide. So when you're doing these, you're going to either swap and drop if you have to write the formula. If you're writing the name, you just ignore all the numbers and you just put down the name of the cation. Anion changes to IDE unless it's a polyatomic ion.